Hi everyone. Before I get started, hit the like button and don't forget to subscribe to my channel. Sorry, all the YouTubers say that, so I figure I had to too. Anywho, today we are going to learn about combustion reactions. And real quick, I'm just going to start out, dive right in. When you look at these combustion reactions, and you're just like looking at what are you noticing about these guys? Right? So we look here and look here, look here and look here. I'll zoom in. Look here and here. What are you noticing that they all have in common? And I hope by now you're kind of seeing a pattern with all of these combustion reactions, that each one of them, every combustion reaction starts with a carbon-hydrogen molecule, a carbon-hydrogen molecule or a carbon-hydrogen compound. Every single one that we start with has carbon and it has hydrogen all in it. So if we go here and we click on our pen, we have carbon, and we have carbon and hydrogen. Sorry, I can't get my stylus working. We have carbon and hydrogen both. Okay, so carbon and hydrogen both. Down here we have carbon and hydrogen both. Carbon and hydrogen both, right? Everything that we start with always has a carbon and hydrogen, always has a carbon and hydrogen. Whenever you start with a carbon-hydrogen based molecule, okay, they're called organic molecules. When carbon and hydrogen are like the primary elements within the compound, you should get like a warning flag, like this is strange, right? Because a lot of people think that this kind of looks like a single replacement reaction. A lot of people say, okay, here's my A, here's my B plus, and here's my C. And oxygen is going to want to come in and kick out one of those guys, right? And so because carbon can have a positive and a negative, it's oftentimes one of the most popular compounds that we have, and hydrogen is plus. And so oxygen being a minus ion, which one is it going to come and kick out? So a lot of people think, oh, this is a single replacement. But when you see something that looks like this, where you have positive, negative carbon, positive, and then you have this negative oxygen coming in here, or positive hydrogen, I should say, and you have this negative oxygen wanting to come in here. Is it going to, which one is it going to kick out? And so what actually happens is every single time you have a combustion reaction, you end up with carbon dioxide and water are your two products. And you should know that, because when you look here and you're like, okay, so this looks like a pattern for a single replacement, this oxygen is going to want to come and kick out who? And so that sends like a warning flag to your brain. And it's like, oh, okay, well, I don't know which one it's going to kick out, but if it's carbon hydrogen, I know it's carbon dioxide and water. So every single time you start with a carbon hydrogen based molecule compound, the products will be carbon dioxide and water. Every single time. So down here, again, oxygen is a -2 charge. Hydrogen is a +1. Carbon is a plus or -4. And so people want to say, okay, negative is going to come in and kick out one of these. And when you see this plus or -4, that should send off a warning flag to you, being like, this is strange. Let's check. Is it carbon and hydrogen? Yep, it's carbon and hydrogen. So if it's carbon and hydrogen, I know my compounds of my products will always be carbon dioxide and water every single time. Looking here, I have a carbon-hydrogen-based molecule trying to bond with oxygen. Every single time, carbon dioxide and water. Every time. So if you see this pattern where you have a carbon and a hydrogen that you're starting with, and it's bonding with oxygen, you will know every single time it's carbon dioxide and, oops, suppose I should spell out water. And we know carbon dioxide is CO2, and we know water is H2O every time. Okay, so the trick about these ones is identifying when there's a carbon hydrogen plus an oxygen. Oxygen, to get oxygen to bond to anything, it usually requires a lot of heat, a lot of energy. And these reactions are typically your fire reactions, your explosion reactions. These are some of my favorite demonstrations to do when we were in the class. But since we're doing distance learning, I can't light you guys on fire. I can't make a, small like bomb in a Culligan water cooler jug. So we're just going to have to go off of this. We got carbon and hydrogen plus oxygen. Every single time we know it's CO2, carbon and oxygen, and water, H2O. Again, I have carbon and hydrogen as my base plus oxygen. The key is that plus oxygen. I know it's going to be CO2 and water. Again, CO2 and water. Every single one of these. CO2 and water. So your homework or your assignment for this week in class is to finish this page, which is page 12. Okay, we got to finish page 12. So page 12. Okay, so you got to submit page 12 to me before the end of the week, page 12. And then you also need to submit page 13 to me by the end of the week. Okay, and you can see how long it took us to finish all these. And guess what? They all have the same answer. You can see they all have the same answer: carbon dioxide and water. Carbon dioxide and water. That's the key to doing combustion. Identifying if it's a combustion reaction because you have a carbon hydrogen starting with oxygen, and your products every single time will be carbon dioxide and water. Okay. All right, so that's all we got learning for this week. I would, if I were you, to start preparing for your test next week, I would review these notes. This is a really helpful kind of overview notes. It has all the different types of reactions. It has our decomposition, our synthesis, single replacement, double replacement, and combustion. It has every single kind of reaction that we've talked about in our on-level chemistry. Review those notes, know those, and then start working on this. Start working on this review. If you can do this review, these 3 pages that we have here for review, yeah, you should be good. You should be good to go for your test. And that's all we got. All right. Don't forget to hit the like button and subscribe. Thanks.